So in this video we're going to talk about total, average, and marginal physical product. And the first thing that's worth noting about all of these ideas is that we're talking about a real physical product. So we're going to get to the difference between total, average, and marginal, but first I just want you to notice that we're talking about a real physical product. So the example that we're going to work with in this video is a farm, and we're going to have a 100-acre farm. So I'm just drawing this small so that I have room for a lot of other stuff later. So we have a 100-acre farm that's filled with rows of crops. So 100 acres. So first we're going to deal with total and average physical product, because I think that those are a little bit easier to use and easier to think about. And then this green stuff we're going to come back to later on in the video, and that's when we'll start talking about marginal physical product. So to work a farm, let's say that you only need land and labor. So you need land to farm, obviously, and then you need farm hands to work it. So you need laborers. So we're always going to farm all 100 acres of this farm. So we are always going to be working with 100 acres. So now the decision is, or the thing that we're going to be talking about is, how many units of labor should we have? So kind of the logical place to start is just with 0 units of labor. And so if we have 0 units of labor working this land, I don't think any crop is going to grow itself. I mean, maybe if it's left over from last year it could, but let's just assume that it won't. So with 100 acres of land and no one working on it, we're going to say that our total physical product, and I'm just going to abbreviate physical product PP because I'll run out of room otherwise. So our total physical product is going to be 0. Now let's go ahead and do another row. So let's say that we have one person working the land, and let's say that we're going to farm corn. So I'll put that up here too. We're going to be farming corn. So we get, let's say with one person, we get 5, and we'll call them bushels. So we'll put 5 bushels. So now we're going to go ahead and kind of create another column here and go ahead and talk about average product also. So the average physical product, PP, and then this is going to be of labor. And this is important, and this is kind of the new thing to start thinking about. So we could do the average physical product of land, but that won't be very interesting, and you'll see why in a little bit. So the average physical product of labor, this is just equal to, and I'll put this up here, this is just the total product divided by the number of labor. So the number of units, I should say, the number of units of labor. So all it's saying is not taking into account land, and that's going to become more important later, you'll see. It's saying just with respect to labor, just dealing with labor, what is the average product per unit of labor? So if we had one worker produce 5 bushels, then our average physical product of labor is just going to be 5 divided by 1, which is going to be equal to 5 bushels. And this is 5 bushels, and the correct units are per worker, because this is 5 bushels on top divided by 1 worker. So we have 5 bushels per worker. Okay, now on to a little bit more complicated example, or a little bit more complicated row. So let's say then that we have 2 units of labor. And let's say that our total physical product now is 12 bushels of corn. So our average physical product of labor then will just be 12 divided by 2, 12 from here and 2 from here. And that's going to give us 6 bushels per worker. So you can see by adding that second laborer that there's a benefit in our average product of labor. So we become more efficient. Us working together, so let's say I was the first guy and I was just working on my own. By hiring another person, we can split up the work and both be more efficient, because our average physical product increases when we hire another worker. So now we're prepared to talk about the next concept in this video, the one that I was kind of skipping around at the start, the marginal physical product. So we have, I'm just going to write it here and then I'll go ahead and start talking about it. The marginal physical product, and I said I was abbreviating that PP for all of the others, so I'm going to do it here also. So the marginal physical product of labor. So that's why I typed this out up here so that you can look at it, you can read it, you can kind of digest it as I keep on talking, and then that I don't mess up any of the wording and don't confuse you at all. So the marginal physical product of input A, and here that's better just to read as labor, is the increase in quantity produced. So it's going to be the increase in quantity produced when the amount of labor used in the production process is increased by 1, holding all other inputs constant. And this part right here, this holding all other inputs constant, is really, really important. So the only other input that we have in this model is land. The only other input we're working with is land, and land is always constant. So we don't need to worry about this in this example. But if land was changing from like 100 acres to 50 acres here, and then from 50 acres up to like 70 acres over here, then we could never calculate a marginal physical product of labor for the first or second unit of labor, because land would be changing. So the other inputs have to be held constant. And in this example they are, and that's why I started with an example that's like farming, that's kind of simple. Okay, so we want to find the increase in quantity produced when the amount of labor used in the production process is increased by 1. So when we go from 0, oh, I just realized something. I skipped what the average physical product of labor would be for 0. So 0, if nothing is produced, the average physical product of labor would be 0 divided by 0, which is undefined. So there's no average physical product of labor here. And we can't have the marginal physical product of labor either, because we don't have any increase in units of labor. You can't increase from -1 units. So in the first row, both of these are just going to be blank. Alright, so now we're actually prepared to talk about something interesting. So if labor increases from 0 units of labor to 1 unit of labor, that's a 1 unit increase. Total physical product increases by 5 bushels. So it goes from 0 to 5, so that is plus 5. So our marginal physical product of the first unit of labor is going to be 5 bushels of corn minus 0 bushels of corn, that increase in total productivity, divided by 1 minus 0, the increase in labor right here. And that's going to equal 5 divided by 1 will be 5. So just right here I want to stop and point something out. The marginal physical product of the first unit is equal to the average physical product of the first unit. And that is always going to be true, because when you increase labor from 0 to 1, whatever your total product is going to be your average product, and it's also going to be your marginal product, because we are in both cases dividing by 1. In the marginal product case, we're dividing by 1 because we increased labor by 1 unit, and in the average physical product of labor case, we're dividing by 1 because we only have 1 unit of labor. So I hope that that's clear. If it's not, pause and rewind and just kind of listen to it again, and you'll see why, and once you see why, you kind of never forget. But we're going to see that the marginal physical product of the second unit does for no reason need to be equal to the average physical product for the second unit. So this little kind of aside is only true for the first unit. So now let's hop on to the second unit. So the marginal physical product of the second unit of labor, we're going to see that we increase labor by 1 again, and we increase total physical product by 7. plus 7. So our average physical product was 12 divided by 2 because we had a total product of 12 and we had two people working on the farm. So on average, the workers produced 6 bushels per worker. But the marginal physical product of the second unit of labor is going to be 12 minus 5, which is where I got the 7 from, divided by 2 minus 1, which is where I got this 1 from, right here. So 2 minus 1 is 1, and 12 minus 5 is equal to 7. So the second worker had a marginal physical product of 7 units of corn, 7 bushels of corn, I should say. And I don't have room to write bushels, so I'm not going to. So that second worker had a higher marginal product than the first worker. The other thing that I want to point out is that average physical product from between workers 1 and workers 2 increased because 6 is bigger than 5. So one general rule that you should also know is that if the marginal physical product is greater than the average physical product, then the average physical product will be increasing. And vice versa, if the marginal physical product is less than the average physical product, then the average physical product will be decreasing. And we're going to go ahead and graph these later and kind of provide some intuition. That'll probably be in the next video. But for now, it's enough to just understand that if the marginal physical product is less than the average physical product, then the average physical product will be decreasing. That's in yellow. And then if the marginal physical product is greater than the average physical product, then the average physical product will be increasing. And I'll provide a little bit more intuition for why that is, probably in Excel, because I think it's the easiest way to see it. Alright, so we're just going to go ahead and do one more row to make sure that we're all on the same page, and then we will go on to the next video. So let's say now that I go ahead and hire 2 more workers. So we're going to jump from 2 directly up to 4. And let's say that our total physical product, let's say that it goes up to, trying to think what would be a good number. So let's say that it goes up to 32 bushels of corn. So then the average physical product of labor will be 32 divided by 4. So we are going to have 32 divided by 4, which, if I am not mistaken, is equal to 8. So that is 8 bushels per worker. Let me just check that. 4 times 4 is 16, times 2 is 32. Cool. Alright, so then the marginal physical product of labor, here we jumped by 2. We increased the amount of labor by 2. So we are going to have 32 minus 12, this increase right here, and that is going to be an increase of 20. And so 30 minus 12 divided by 2, and actually, you know what, I'll write that differently. Divided by 4 minus 2, because that is the amount of labor that we had here minus the amount that we were working with in the previous row. And so this is equal to 32 minus 12 is going to be 20, and then 4 minus 2 will be 2, so 20 divided by 2 will be 10. So the marginal product of the 4th unit of labor, the 4th worker, was 10 bushels. So I'm going to go ahead now and end this video. In the next video, we'll continue with this example in Excel, and we'll talk about some more rules and graph this and kind of get some intuition for what's going on.